Howdy, everybody, and welcome to the March Grafana community call. Um, yeah, so we got a few things on the agenda today, and we will just jump right into them as soon as I pull it up. I think the first thing is internally we had talked a little bit about we do a bug scrub where we kind of go through the backlog. And some of the other teams, I believe, have that opened up, and we were trying to see if anyone had any interest, interest in either attending or whether as a whole we want to open it up. So I'll open it up for any comments. Strong opinions.
I mean, it'd be a good opportunity to for people to find out why we might not be working on something and to discuss. Maybe encourage people to contribute if we don't have the time to kind of put our time into something. I'm saying time too many times. I don't know. I'm not opposed to it. It kind of feeds into our whole open by default thing. But it also might be a pretty boring call for a lot of people.
Scouts?
My 2 cents is that if we have some issue that has a very long back and forth thread of communication and async communication takes time, we could invite the specific person that wants to discuss it in the bug scrub so that they can provide their feedback right there, right away. I don't know if we have any such issues right now.
I think that's a pretty excellent point. And ideally we did, yeah, I think it's a good point.
The one trade-off there is, well, I think we'd have to be careful to not do that too often because it might make things take longer, right? But I think if something's has that much discussion, it's probably already taken quite a long time anyway.
Yeah.
So saying let's discuss it on a call during the next bug scrub probably wouldn't change anything. So yeah, I like that idea.
Cool. My personal vote would be to do it, but say we wouldn't necessarily record it just because I don't want to spam the YouTube channel with very boring bug scrubs.
Good point.
Okay. It sounds like we have rough consensus to do it.
For those who aren't aware, we do the bug scrub every 6 weeks, something like that.
Yeah.
Yeah, it will literally be 6 weeks from today, right? If we did it right before this call. So I will add a to-do, that term, schedule it on the community camp channel, and set up new agenda / invite, I guess. All right, cool. Scouts, you're up about covering relabeling rules a little bit.
Yeah. Can I share my screen?
Absolutely.
Okay. Just to set some ground rules here, feel free to interrupt, and it's not like a teaching class or anything. I want to start a discussion, and if anybody spots a mistake or has a better example or a more interesting use case to discuss, then feel free to do so right away. Can you see my screen now? Great. Okay. So I guess everybody's heard about relabeling rules, right? Is anybody who's not aware of them at all?
Let's pretend I don't know what they're about.
Yeah, in any case, yeah. So relabeling is a Prometheus tool that allows to classify and filter Prometheus targets, that is machines that are being scraped, and metric series by rewriting their label set and actually either adding more labels or dropping them altogether. And let's start by establishing some terminology about what labels are. And labels are just key. Does the screen scroll down or no?
Not right now. It's not.
I can see your cursor moving though.
Yeah, I don't know why it's not scrolling downward. So let me try that again. Sorry. Now should be good, right?
Yes.
Yeah.
Okay, so Prometheus generally ingests metrics on a line-oriented format. That means that each line is a new metric or a new metadata line that should be parsed and ingested, stored, etc. Where there's a metric name, there's a bunch of key value pairs that are these labels, the value of the metric, and an optional timestamp. And what Prometheus does is that it treats its unique set of labels as a separate metric. So these key value pairs can be used to quantify, for example, if I'm measuring HTTP latency, then they can be used to classify which endpoint has been called, which HTTP method was used, which was the status code returned, or which server served the request, for example. And each unique combination of these values is going to be a separate metric stored in the Prometheus database. And that also feeds into why labels are important for a metric's cardinality. We shouldn't be using labels for things that have unbounded values like usernames or user emails or session tokens or anything like that. And someone will also raise a concern here. What about metrics with no labels if we haven't defined anything? There are some internal labels that are being set by Prometheus itself that they have to do either with the metric name, where the scrape came from, which path was used to scrape, any URL parameters that have been passed, or special labels set by the service discovery mechanism. So if I go here and see how we can configure Prometheus to scrape different targets in a Kubernetes environment.
I don't think
I
you
don't know
prayed
what's
enough
taking
to the
so
demo
long.
gods before this.
Come on. I didn't pray at all. It's all improv. So yeah, I hope I haven't bored you to death right now. And we can go ahead and see how a relabeling step looks like and what we can do with this. Again, if you want me to stop and put you out of the misery, just let me know, okay?
You're doing great, Pascal. Don't worry about it.
Okay. So a relabeling config consists of these 7 fields, which define a relabeling step. And a Prometheus configuration file may have an array of relabeling steps that are applied in order of appearance. And they can also be applied in different parts of a metric lifecycle, which we'll discuss later on. But just to see and understand what we're talking about, the actual fields that you can configure are the source labels, the separator, the target label, an optional regular expression, which defaults to just getting everything that has been concatenated by the values above, a positive integer that's being used in very special cases to perform a modulus operation. We'll talk about this later. What we're going to replace the target label with, just this will also be explained later, and the default to just everything, and what action we want to perform. So the source labels field expects an array of 1 or more label names, which then select the respective values. And if there's more than one source labels, they will be concatenated by the provided separator. So in the following example, if we have this custom counter, which points to two different servers and a specific subsystem, if we have the two source labels and this separator, we'll end up in extracting those two values, like kata at web server 01 and kata at SQL database. Is that clear? Okay. And then we can use a regular expression to actually extract specific fields from these concatenated values and either continue with the next operations if the regular expression passes, or just abort execution if the regular expression doesn't match. So here we could match everything that comes after the kata at concatenated values and perform some operations only on those metrics or only on those targets. Or we could just filter out all the subsystems that operate on a Redis cluster, for example. Keep in mind that these parenthesized values can be referred to later on as a capture group, so this allows us to get more creative with what we can populate in a target label. And here, the replacement value will actually tell us how it can use these capture groups in order to populate a target label. So for example, continuing on with the previous one, if we have the subsystem and servers with an NAT separator, and we captured those two different groups, and we wanted to change their order around by adding a slash in the middle, we could end up extracting these two values. Does it make sense? Okay. And of course, the target label is the actual label which in which the result of the replacement will end up populating. So if we continue from the previous example and concatenate it all in a big block, then if we had those two source labels and captured the different parts with a regex and replace them onto a my new label, target label, then we would see that there would be one extra key value pair added to the specific metric, which would look like that. And finally, the modulus field expects a positive integer, which was kind of weird when I first read about it. What it did is take an MD5 of the extracted value, that means the concatenated label values with a separator, and perform a modulus operator, a modulus operation based on this positive integer. And we'll see in a few what we can do with that. So what can we do with these building blocks? How can they help us in our day-to-day work? The first thing that we can do is instruct Prometheus to actually keep or drop specific targets and metrics based on whether these label values match the regex or not. And if we go back to the previous example, we could actually have a Prometheus drop the kata at web server scrape target so that no more metrics coming from there would be ingested. Or we could, on the other hand, just have the same source labels, perform a regex, and just keep everything that comes from the kata subsystem, and then just drop by default everything that comes from other servers, for example. And in cases that we've had to support the community requests, this can be useful in like keeping only custom metric names if you have metrics with high cardinality, or use it in accordance with what labels your service discovery mechanism exposes. So that, for example, you can use something like this to drop everything from your testing and staging Kubernetes namespaces, so that only either scrape targets or metrics coming from your production namespace could get through. Next up, and in a pretty similar manner, there's a label keep and label drop action that we can have, which allows us to filter the label set themselves. And it's not about dropping specific machines, scrape targets or metrics at this point, but just trimming down the labels, the label set itself. But the thing is, yeah, go ahead, Robert, sorry.
No, I just saw, I was going to mention your last sentence there, but I noticed you wrote it down now that you scrolled.
This one?
The one below that, the make sure that the labels are unique after doing that.
Exactly, yeah. So as we mentioned above, Prometheus treats its unique combination of the label set as a different metric. So if we dropped, for example, the subsystem label here, and we had both kata at web server and kata at SQL, and if they had different values, Prometheus wouldn't know which one to ingest. I don't know what would happen in this case. Robert, do you remember? Would it just ingest either of those, or would it error out?
Sorry, can you repeat the question again?
Yeah, of course. So in the previous example, sorry, here we had these labels set, okay? And
Yep.
if we actually dropped the server label and we ended up with two metrics that had the subsystem kata value, what would happen to those two values? Would Prometheus select one at random, or would it error out?
Well, okay, so it depends if they're from the same target or for different targets. If they're from different targets, then it's effectively whatever gets scraped last. But as long as they have the same timestamp, then the most recent sample will be accepted. If they have different timestamps, then you'll get out of order errors.
Okay.
You might, yeah.
Let me note that down. Maybe it would be good to explain what happens here.
I would honestly just say undefined behavior. Like there's a lot that could happen and it's hard to predict.
Okay, and then moving on, they replace the default action for a relabeling rule if we haven't defined one. And what it does is just replace the value of a given label with the replacement, what's in the replacement field. So in the simplest of cases, you can use these to just replace the env label with the production value, to just hard code things, which is the most common use case, I think. Or you could do more fancy things like having the source labels being the address and the port number and concatenating them, performing a replacement using the Regis capture groups and then passing them over to another label. And finally, the hash mode action is what makes use of the modulus that we discussed previously. It actually performs a modulus operation and then can be used to actually keep or drop targets based on the value of this modulus operation. I think an example here could make things clearer. If we have that custom metrics with labels node and val, name and val, and we perform the modulus with a value of fate, then what it would do is populate this target label TMP hash mode with the result of this calculation. It would just take an MD5 hash of the concatenated string, perform the modulus by 8, and the result is 5, so it would just populate this target value with 5. Then we could just have another step, another rule that would keep only either metrics or either targets that have a specific number in the TMP hash mode value. And this can be useful when we want to like horizontally scale Prometheus. You could have 8 Prometheus instances and just route targets who end up having this value from 0 to 7 respectively. Is there anyone who can have a better example for this, like Matt or Robert?
I think HashMod was designed specifically so you could shard your Prometheus servers. You typically do it based on the address label of the target, but if you wanted to shard on different labels, there's no reason you couldn't do that.
Yeah. And finally, the last action is the label map, which can be used to map one or more label key value pairs to different label names. So for example, the Kubernetes service discovery, as we mentioned before, exposes a number of internal labels that start with a double underscore, and that means that they will not be present in the final label set of the metric, and this unless we explicitly configure them to be. And what we could use a label map here for is to just perform a regex capture of this kind of names. So here it would capture as a first group the pod, and as a second capture group the container name. And we could just replace that value with a KH pod underscore container name, thus actually keeping those label values and not discarding them at the end of a scrape cycle. I'm not sure if this was a very good explanation. Okay, and one last thing is that a confusing part of relabeling rules is that they can be found in different parts of a Prometheus config file, and that's why it took a long time for me to actually understand how they work and why my metrics weren't showing up. They can be defined as both under the relabel configs and metric relabel configs key. They can also appear under a remote write key with the right relabel configs header. And they can also appear as alert relabel configs under alerting, or under relabel configs under an alert manager, which is super confusing. I don't know why people at Prometheus thought this was a good idea. The difference between those is that these rules are applied in different parts of a metrics lifecycle. So the first one here is applied directly when the metrics is first scraped. So dropping something here means dropping the entire scrape target, the entire machine that you're scraping, so that you won't get any other metrics, any other metric series from that machine. While the second block here is applied after the scrape happens, but before it's ingested in the Prometheus time series database. So you can have access to all of the metrics that the machine provides, but you can drop ones that are too expensive for you to actually store, or a metric with high cardinality. And the right relabel configs in the same manner are applied just before we send things over to a remote write. So this can be also used to like filter very expensive metric series from being stored in a remote write, or just figure out which remote write you want to receive which specific series. I don't know if we actually do that here, or if you have any real world examples of this. Yeah, go ahead, Robert.
Yeah, can we go back up real quick? So relabel configs, those are applied before scraping. After, I think it's probably best to say after discovery, but before scraping. Then metric relabel configs happens during scrape. for every sample that you see, and that's before it gets added to the rate ahead log. And then rate label configs happens at like when the rate ahead log is being read for sending stuff out to the remote endpoint. So the first two happen before you store things on disk, and the last one happens after it's already on disk. The remote write relabel rules are useful for splitting up what you're writing to do different endpoints. So maybe you want to send team A's metrics to endpoint number 1 and team B's metrics to endpoint number 2. You could use write label rules to do that there. Or injecting new labels, whatever you want to do that's specific to a remote write. But it's mostly used for dropping things or splitting them up or adding new metadata.
Okay, so if we wanted to just preserve service discovery labels, we'd need to do this right here, right? Because they wouldn't be available when after the scrape.
Yeah, any label starting with 2 underscores gets removed after the relabel configs.
And finally, the last place where this can be used is in an alert manager configuration. And correct me on this, but I think that this also follows the same pattern. This triggers out, let me see here. I think this one can make sure that the alerts that are sent to remote alert manager are standardized, mainly. And this is used to see to which alert manager we should post an alert to, right?
I actually don't know about this one. This isn't in the agent, so I have no knowledge about how the alerting rules works.
Okay, so without having prepared anything at all and being a little petrified, that was me wasting 15 minutes of your time. But if you have any feedback or questions that we could spark up a proper discussion, that would be great.
Yeah, I don't think it was a waste at all.
Yeah, you did a good job. Relabel rules are a big source of confusion for a lot of people, especially because there's a lot of fields that only apply if you're using a certain action. And having a doc like this is really, really useful.
Yeah, I mean, whenever I needed to reference anything, there was like one blog post that I would consistently go to that talked about the differences. So actually, that blog post was not on Grafana.com. It was just a random blog post. So having a document and having this handy will be excellent.
Do you think that we should add like more examples on this blog post or more technical explanation of why things happen a specific way? How would you make this more approachable and more useful to end users if we were to publish this like tomorrow?
I think the rules that we talked about, like when does a relabel config and metric relabel config, I don't know if that was totally defined in this doc. But maybe having that be more, like just a brief like bullet pointer description of those would probably be helpful on when to apply them.
I think maybe coming up with a list of the most common use cases that people want to use relabel rules for, and then saying something like, if you want to drop metrics because you have too many, you want to use metric relabel rules. If you want to change metrics before they are written, you want to use metric relabel rules, stuff like that. So that way, I think what you have is good. And then having just a list, like a bullet point list somewhere at the bottom of like example use cases and what to use or what to mix would tie it all together to help people understand it a little bit better. It is a very flexible tool, and until you get really familiar with it, I think knowing how to use it to solve a specific problem might not be super obvious.
That's a good idea. Yeah, I'm writing it down.
Thank you. That was really good.
Yep, fantastic.
I hope you're not only saying that because we're recording.
Cool. Any other questions for Pascal's? All right, we'll do open topics or agenda. Anybody has anything they want to talk about? Here would be your time to do it. All right, if no one has anything else, then I believe that is the full agenda. I don't have it open right now. It's in a different tab. So, all right. If no one has anything else, then we will hop off and give everybody some time back. And this will get posted up generally later today. All right.
Thanks,
Thank
Matt.
you, everybody.
Appreciate this.
Have a great day. See you.
Bye-bye. Thank you.